Hello all, welcome back to my channel. This is Sushi, your host. So today we are back with module 2 where we are going to discuss more concepts about electric charges and field. Again, talk about the previous module. So if you have missed my previous module, please watch that module. That's module number 1 based on electric charges and field, where we discuss a very important concept based on what is an electric charge, the types of charges. Yeah, so that's very important. So to begin with this module, we'll have a quick recap of the previous module. That's nothing but how do you define electric charge? So what's an electric charge, my dear students? An electric charge is nothing but it's a property possessed by a material or an object that can exert a force or respond to a force. So in this module, we are going to learn something about conductors and insulators, which you know from your lower classes, but still we will learn something more interesting about them. Yeah, so please do enjoy this module. Have a happy learning. Please stay safe. Okay, so we have conductors and insulators. In this module, we'll be discussing on this topic, conductors and insulators. Now, what are conductors and what are insulators? I'm 101% sure that all of you know what are conductors. So you will say that conductors are the materials that allows the charges to pass through it, okay, or that allows to conduct electricity. And you are perfectly right. So conductors are the materials that allows the charges to flow through them. So you can see that metals like copper, aluminium, and silver are called conductors. Now, why are they called conductors? Please understand. They're called conductors because they allow the charges to pass through them. So you can see this copper, aluminium, and silver. So conductors basically conduct electricity. They allow the charges to pass through them. Now, same way we have substances like glass and wood, which are called as insulators. Now, why are they called insulators? You already know the answer. You already know the definition, because insulators are the materials that do not allow the charges to flow through them. So basically, they do not conduct electricity. So this is a glass, this is a wood. So we know that insulators do not conduct electricity. So conductors have large number of free electrons. Please understand. That's why, that's why the current can pass through them. Since they have large number of free electrons, if you have studied the definition of current, what is current? How do you define current? The rate of flow of charge is called as current. So in conductors, the charges can flow easily. That's why we say that conductors conduct electricity. Whereas in insulators, we do not have those free electrons. The number of free electrons are very less. That's why insulators do not conduct electricity. Now you can see this example here. So you can see that copper wires, okay, the wires what we use at our home, if you bisect them, okay, if you just cut and see there, you'll see a copper kind of wire there. Now please understand, those copper wires are the one which conducts electricity. And you see that there is a rubber coating on the outside. Now why is that rubber coating? Because it acts like an insulator, because rubbers do not allow the current to pass through them. Yeah, so that's about the slide. I hope you have understood. So why rubber is used as an insulator and why copper is used there. Yeah, okay. Now if you see this, we have a gold ball here which acts like a conductor. Now when I bring a charged particle closer to it, what happens is you can see that the charges get distributed easily in a conductor. Please understand, since conductors can conduct easily, since conductors are having large number of free electrons, they distribute themselves very easily. So you can see that when extra charge is given to a conductor, it instantaneously gets spread over the surface of the conductor. Why? Because conductors allows the movement of charges. But when the same thing I do in case of an insulator, you will see that the charges don't get distributed. So let's go through that. So you see this now. Now when I give an extra charge to a rubber ball or a plastic ball, it acts like an insulator. Now can you see the distribution of charges here? You cannot. Why? Because charges don't flow easily in case of insulators. So you can see that when extra charge is given to an insulator, it remains localized. There is no movement of those electrons, or there is no movement of charge particle. Now, how objects become positively charged, my dear students? if you have heard my module 1, or if you have listened to my module 1, I've spoken about this concept already. So when do we say that a body becomes positively charged? I hope you must be in a condition to tell me the answer now. Yeah. So when does a body is said to be positively charged? Please understand. When electrons are lost from the body, or when you remove electrons from the body, we see that the body becomes positively charged. So if you observe now, if you observe here, so you can see in this example, that what is happening? What is happening in this example? Let's understand. So if electrons are removed from a neutral atom, yeah, so what happens is the conductor becomes positively charged. So that's what I'm talking simple terms. I'm telling you in a simple way that you just remove an electron. What happens is, from an atom, when you remove an electron, it remains with positively charged particles. The number of positively charged particles are more, because I've already said that inside an atom we have proton, we have electron, and we have neutrons. Correct? Protons, electrons, and neutrons. Now, when I remove this electrons, the negatively charged particle, what is remaining there? I have more number of protons. So that is how it becomes positively charged. So now if you observe here, we have a neutral atom. So you can observe the slide there. So inside the neutral atom, you can see that there are equal number of positive and negative charge. Yes or no? We have equal number of protons and electrons. Yeah. Now if I remove an electron, what happens? So I've removed an electron. You can see in the slide the electron has gone off. Now what is happening? The number of protons are more. So we say that a body becomes positively charged. So a deficiency of negatively charged creates a positively charged body. I hope you're clear. So let's have a summary in a simple way. You remove an electron, the body becomes positively charged. That's it. Yeah. So let's move ahead. So you can see that the conductor has become positively charged. So let's move ahead now. How does a body becomes negatively charged? Now, my dear students, if you use your common sense, what I always talk in the class, if you are smart enough, if you use your basic common sense, can you tell me what will be the answer? So I can hear most of you telling me the answer. I can hear that scream. I can hear that noise that you are telling me. When we add a negatively charged particle, when we add an electron inside a body, the body becomes negatively charged. And you're absolutely right, my dear students. The answer is perfect. So you can see that if an extra electrons are added to a neutral atoms of the conductor becomes negatively charged. That's a perfectly right answer. So you can see that neutral atom. Now you can see that I have equal number of positive and negatively charged particles are present there. Now observe, I have added an extra electron. So now what happens to the body? Can I get the answer? So the body becomes negatively charged. So you are absolutely right. Yeah. So the body becomes a negatively charged body. So my dear students, that's all in this module. So I hope you have understood what are conductors, what are insulators, and we had a quick recap of positively charged body and negatively charged body. So thank you so much. So please do like the video, share it, and please give your valuable suggestions, your feedback, so that we can improve on this. Thank you so much. Please stay safe, take care, happy learning, enjoy your day, have a great time, my dear students. Thank you so much. Please take care.